The James Webb Space Telescope just spotted galaxies that seem older than the universe itself. Wait, how can something exist before time began? Let's dive into one of the biggest cosmic puzzles of our time. When astronomers pointed the James Webb Space Telescope toward the deepest, darkest corners of the cosmos, they weren't just taking a picture. They were activating a time machine. Because light from distant objects takes an immense amount of time to reach us. Looking far away is the same as looking far back into the past. JWST was designed to peer over 13.4 billion years into the past, giving us a glimpse of the cosmic dawn, a period incredibly close to the Big Bang itself. It was built to find the very first flickers of light from the first stars and galaxies, showing us a universe in its infancy. But what it found has thrown a wrench into everything we thought we knew about those early days. In these ancient cosmic landscapes, something truly strange began to appear. Astronomers expected to see faint, messy, chaotic blobs of gas just beginning to coalesce. Instead, JWST revealed galaxies that looked surprisingly mature. These weren't the disorganized nurseries of stars we predicted. Some were bright, well-structured, and shockingly massive. They looked far too developed for their age, like finding a teenager in a delivery room. These galaxies seemed to exist a mere 300 to 500 million years after the Big Bang, a blink of an eye in cosmic terms. Our established models of cosmology suggested that, at this early stage, the universe simply hadn't had enough time to build structures this complex. The paradox lies in their sheer size and brilliance. The mass and brightness of these early galaxies suggest that stars inside them were forming at a rate far faster than our theories allowed. According to the standard model of cosmology, the lambda CDM model, galaxy formation is a slow, gradual process. Small clouds of gas and dark matter clump together over hundreds of millions, or even billions of years, slowly building up into the grand spiral and elliptical galaxies we see today. But these JWST discoveries defy that timeline. They appear so massive that they would have had to start forming almost immediately after the Big Bang and build up their stars at a furious, unprecedented pace. It's like finding a fully constructed skyscraper just a few days after the foundation was laid. The math just doesn't add up. So what is going on? How do we solve this cosmic contradiction? Scientists are now racing to find an explanation, and several compelling possibilities are on the table. The first, and perhaps simplest explanation, is that we might be making a mistake in our measurements. Astronomers determine a galaxy's distance, and therefore its age, by measuring its redshift, how much its light has been stretched by the expansion of the universe. It's possible that our estimates are off. Perhaps these galaxies are not as far away as they appear, meaning they are younger and their development is less surprising. Or maybe the dust and gas within them are affecting the light in ways we don't yet understand, making them appear older and more massive than they truly are. It's a case of cosmic forensics, and every clue is being re-examined. Another, more exciting possibility is that our understanding of physics needs a fundamental update. The standard model has been incredibly successful, but it might be incomplete. Perhaps there are new physical laws or forces at play in the early universe that we have unaccounted for. Some theories propose that early cosmic inflation, the period of rapid expansion, just moments after the Big Bang, could have planted denser seeds of matter than previously thought, giving these galaxies a significant head start. Others suggest that hidden properties of dark matter might be responsible. If dark matter interacted with itself, or with normal matter in a way that accelerated clumping, it could have dramatically sped up the process of galaxy formation, allowing these massive structures to form in record time. This would mean we're not just observing new galaxies, we're observing the effects of entirely new physics. Finally, the most mind-bending theories suggest that our entire concept of the beginning needs a rethink. What if the Big Bang wasn't a singular, absolute beginning? Some cosmological models, like cyclic cosmology, propose that our universe goes through endless cycles of expansion and contraction. In this scenario, what we call the Big Bang might have been more of a big bounce, a transition from a previous cosmic phase. If that's the case, these seemingly ancient galaxies could be relics or structures influenced by a universe that existed before our own. This idea pushes the boundaries of known science, but the strange data from JWST is forcing us to consider even the most radical possibilities. It challenges the very narrative of a single origin point for time and space. One thing's for sure, JWST has done its job spectacularly. It's made us question what we thought we knew. The universe isn't simple, and every new discovery reminds us how much more there is to learn. These impossible galaxies aren't a sign that our science is wrong, but a thrilling invitation to make it better. They are puzzles handed to us from the dawn of time, waiting for a new generation of scientists to solve them. No magic. Just physics and a telescope that's rewriting cosmic history.
Stay curious.